All right, so we are looking at compound events today. So where we're doing more than one thing. And we're going to look at independent and dependent events. So how can one event impact a second event in a probability experiment? So I've got this bag. It's got 2 red and 2 white tiles in it. And they're asking me what's the probability of pulling red and then red. So let's look at the 2 different ways. So an independent event would be when the first option does not affect the second. So the first event does not affect the second event. So if I'm reaching in here to pull a red, right now I've got a 2 out of 4 or a 1/2 chance to pull a red out. If I put this back in, I put the red back in, then my options stay the same. That makes this independent because I didn't change my options for the second pull. The second pull, I still have 2 out of 4 or 1/2 of a chance to get a red. Okay, and then to solve these, I would just multiply. Okay, but there's my first and my second. For dependent, what's different here is that after I do my first event, it has changed the options for my second event. So I reach in to pull out my red. I've got a 1 out of every 2 or 2/4 of an option. But now I've pulled it out, it's gone. Okay, so now for my second choice, I don't have that one. I've only got 1 out of 1, 2, 3 tiles left over. So see how the first event, me pulling that red, changes the options for my second event. That is dependent. So dependent when the first event alters your second event, independent if the 2 do not affect each other. Okay, so now let's decide if these are independent or dependent events. Remember, independent, the 2 events they don't affect each other. For dependent, the first event changes the possibilities for the second event. So Sierra is drawing raffle tickets. She's already drawn a ticket for the first prize and will next draw a name for the second prize. These 2 are dependent because when she draws that first name out, it's gone. She's not going to put that ticket back in there. So that person is not available to get second prize as well. Okay, second option. Jared selects a box of cereal for his family at the supermarket. Across town, Alondra also happens to pick a box of cereal for her own family. Okay, these 2 are independent. Because think about it, when you take your box of Lucky Charms off the shelf, it doesn't disappear off of the shelf at a different store. That doesn't make any sense. So it doesn't change the likelihood of Alondra getting Lucky Charms or not at her store. Okay, Elizabeth spins a spinner twice. These are also independent because when you spin a spinner, you don't then take it off of like the wheel, right? It's still on it. So you can keep spinning the same spot more than once. And the last one, you pick a card at random without putting the first card back. You pick a second card at random. It's this without putting the first card back. Sometimes it will say without replacement. That is what makes these 2 dependent. Once I have taken the card out and I'm not putting it back in, it's no longer an option. Now let's go ahead and solve some. So 1 letter tile is selected and the spinner is spun. What's the probability that both will be a vowel? So the way that we solve these is we are going to find the probability basically of each, and then we're going to multiply them. So the first event is we're picking a vowel from these letters. So there's 2 vowels out of 4 options times a vowel on here would be 1 out of these 3 options, 1 out of 3. You can just go ahead and multiply this and then simplify at the end, or if you want to simplify now, you're welcome to. Sometimes I like to do that just so I don't have to use such big numbers, but also we have calculators, so it doesn't really matter. So either way, if I multiply straight across, I'm going to get 2 out of 12, which I would then need to simplify. Or here, if I simplified, I'd have 1/2 times 1/3, which is 1/6. That's also what that simplifies to. So Oh, we should have answered this at the beginning. Sorry, independent or dependent. These are independent, right? When I pull a letter tile, it doesn't change anything on my spinner. So independent. And the probability is 1/6. Just use that slash. I know it's not perfect, but that's the best we can do in this box. Okay, so remember, find the probability of the first event, then the probability of the second event, and then you just multiply and simplify that fraction. Okay, remember this reads the probability of green, then yellow. So we're going to find the probability of spinning a green and then spinning a yellow. These two are independent. Because once you spin the first thing, I'm not going to take that piece off of the wheel. I can always spin again. So the probability of green, there's 1, 2, 3 out of the 8 total options. So 3/8 for green. Then yellow. Yellow, there's 2 yellows out of the 8 options. And I just multiply those. So 3 times 2 is 6. 8 times 8 is 64. Remember, you do have a calculator if you don't remember that. Or we could have simplified here. So 3/8 times, this is really 1/4, which would give us 3/32. Same thing if we had simplified that, divided each by 2, we would get 3/32. So our probability is 3/32. Okay, the probability of the first event times probability of the second event. Let's do another one. All right, there are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Kim selects a piece of fruit and eats it. Then Terry selects a piece of fruit to eat. What is the probability that 2 apples are chosen? Let's decide if this is independent or dependent. So here, since it says it says Kim eats the fruit. Once she eats it, or he eats it, then Terry can't pick that piece anymore. Okay, it's already gone. So this is actually dependent. So let's think about how that changes our setup here. So Kim selects an apple, right? We're trying to find the probability of 2 apples. So apples are 5 out of, let's see, there are 9, 16 options. Okay. That's what it is for Kim. I'm going to put a little K here so we don't forget. And then for Terry, well, remember, Kim has now eaten one of the apples. So this is not 5 apples anymore. It's only 4. So for Terry, we only have 4 apples left for that person to possibly choose. And not only that, but there's 1 less piece of fruit total in the basket. So it's out of 15 instead of 16. This is where it gets a little tricky, these dependent events. You've got to think about how it changes your numbers here. There's 1 less apple, there's 1 less piece of fruit. Okay. And you can't really simplify these this way, but remember to cross simplify, or just remember to simplify at the end. But I'm going to do some cross simplifying because it's going to make it a lot easier. So 4 and 16 are both divisible by 4. So 16 divided by 4 is 4. 4 divided by 4 is 1. 5 and 15 are both divisible by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. So really I have 1/4 times 1/3, which is 1/12. So the probability that 2 apples are chosen would be 1. Okay. This is a really good one. Come back and watch this part again if you need to see how I'm getting these 4 and 15. I know those are both different, right? They both had to decrease. Okay, just a couple more for us to do together. So what is the probability of throwing a dart at board 1 and getting yellow, then board 2 and getting blue? Okay, so here's what's a little tricky about this one. They're not cut up evenly. So that is what I'm going to show you, is how to kind of do this. I always like to find the smallest piece on the board and kind of follow those lines so that's all cut up. So like this brown piece, I just kind of continue this line over. Okay, not very good, but pretend like that's nice and straight. And this line over, now it's cut into fourths. Okay, this one's already cut pretty good, number 2, and then board 3, just to show you, again, there's my smallest piece. So if I kind of follow those lines to make them all look even, then I can kind of see what fraction of the board that really is. Okay, so now this one's cut into sixths. Okay, so back to my question. What's the probability of throwing a dart at board 1, getting yellow, and then board 2? Okay, we're throwing darts at boards. We're not going to take any pieces off, so these are dependent. And let's see, getting yellow on board 1. There's only one yellow out of the 4 pieces, right? When we cut it evenly, it's a fourth. A blue on board 2, there's 1 out of the 3 pieces. So 1/4 times 1/3 is 1/12. So our probability is 1/12. Okay. The following letters are in a bag. What is the probability that you pick out a G, replace it, then pick a C? Okay. So it says I am going to replace it. So this is independent. Okay. And let's see. So the probability first of getting a G, there's 1, 2, 3 G's out of, let's see, 3, 6, 9 letters altogether. Okay, I did replace it, so I put all the letters back in. And now I'm trying to pick a C. There's only one C out of the 9 options. Okay, so again, we can just multiply these, or you can simplify now. If you simplified right now, this would turn into 1/3 times 1/9. Okay, and if not, that's all right. So 3 times 1 is 3. 9 times 9 is 81. We would want to simplify those, so divide them both by 3. And we should get the same thing we get down here, which is 1/27. So our probability of picking a G, putting it back, and picking a C is 1/27. Okay, one more problem for us to do together, and then you have some practice to try on your own. So same idea, there's our letters. We're going to grab 2 tiles at the same time. What's the probability that we pick out 2 G's? Ooh, okay, this one is a little bit different. We're picking 2 at the same time. That at the same time thing makes this dependent. I can't pick 2 tiles out and have them both in my hand be the exact same tile. They could have the same letter on it, but it can't be the exact same one tile. That doesn't make any sense, right? I have 2 different tiles in my hand. So dependent, it's like I pulled one out, kept it out, and then pulled a second one out. So this makes it dependent. So let's find our numbers. So that means I'm going to pick a G out, basically, and then pick a different G out. So the first G, there's still 3/9 originally. But then we have to assume one of the letters in our hand is one of those G's. So that one's gone. Now I've only got 2 left. And it's not out of 9 tiles. It's now only out of 8 tiles. Okay. Simplify now or simplify later. If I simplify now, I get 1/3 times 1/4, which is nice and easy. Or here I can multiply and get 6/72. I would need to divide both of those by 6, and I would get 1/12. Either way, if I simplify at the beginning or at the end, I should get 1/12 as my probability. All right, so from here, there's a bunch more practice, same kind of ideas. I want you to go ahead and do the rest and then check the key. Thanks, guys.